Hi guys, our second trip to someplace that I wish we could be right now. Actually, inside a TV show. Oh, remember that little white monster guy that sits on my desk right by my eraser thing? Well, he's from this show. This is from Doctor Who. So this is inside the TARDIS, inside the ship from Doctor Who. So, yes, I'm a massive nerd. That's me. I'm proud of who I am. I embrace the nerdiness that is me. Y'all know it. Be who you're supposed to be. All right, so let's get back into the math stuff. We are going to continue on with this graphing quadratic stuff. So today we are actually going to graph, I believe. Let's get over to the question so I can actually see what I'm doing. All right, so let me share that. All right, so it says, yes, it says we're going to graph this equation, which is example 2 from the big ideas. So we are going to graph it, and then we have to describe the domain and range, which is a vocab words that should at least be familiar. We've done domain and range in the fall semester when we did linear equations and things like that. You've done domain and range for other functions, but it's just not something we have done, I don't think, this semester all that much. But we're gonna go through it again. All right, so I still kept up all those formulas that we had on that first page. I chopped off the little graph, so we had a little space. So this is the exact same graph paper that I posted up on Canvas. I have it printable, so you can hopefully, if you have access to a printer, you can print that out. If you don't have access to a printer, just kind of sketch it carefully on your paper, and that'll let you at least get some similar ideas. I think in the big ideas, it has an interactive thing that you might be able to do. Hopefully, I haven't gone through it too much, so I hope it's good. I think a lot of it is matching. So anyway, let's go through this. So what we need to do to graph these parabolas, we need to find all those things we found in the first video. We're going to find our axis of symmetry. We are going to find our vertex. We are going to find our intercept. And then we're going to kind of mirror things over our axis of symmetry. All right, so very first thing is, let me make sure I have a pen color that actually works. I think I'm in yellow. All right, so let's get our axis of symmetry, which I'm going to put AOS because I am lazy. All right, so our axis of symmetry, that means we're going to follow this formula over here. Our x equals opposite of b. Remember, this is our A, our B, and our C way up here. So our axis of symmetry, and our B, in this case, the opposite of our B, we can just go straight into it, is -6 over 2 times our A, which is 3. Let's put parentheses in there. That's why we got to put those parentheses in. So let's simplify this. We're going to have -6 comes to +6 over 2 times 3, which gives us 6. So this is going to be, our axis of symmetry is x equals 1. So what we do is we're going to come over here onto our graph paper. We're going to graph this at x equals 1. And I'm going to switch off the yellow because I'm pretty sure, well, let's see if it shows up. And what we do is we put kind of a dotted line for our axis of symmetry. And that yellow really doesn't show up. So let's get a different color. Let's go red. Should show up. Yeah, there we go. So I'm going to put a dotted line on x equals 1. What that shows us is that shows us where it's symmetrical. So whatever happens on one side is going to happen to the other. Okay, so there's our axis of symmetry. Let's go ahead and find our vertex next. Because we know with this axis of symmetry value, our vertex, we just plug it in. So to get the y value for our vertex, so the y vertex, we plug it in up here. So 3, instead of putting an x, I'm going to put in this x value here. 1 squared minus 6 times, plugging in for this x, that 1 plus 5. Okay, so we're going to solve this out. Y equals 3 times 1 squared. 1 times 1 gives us 1. Minus 6 times 1 gives us 6 plus 5. All right, simplify this out. We've got 3 minus 6 plus 5. So going left to right, 3 minus 6 gives us -3 plus 5 gives us +2. So what this tells us is that our vertex is going to be at the x value of 1 and the y value of 2. So the point 1, 2, whoop, back, there it is. I have to do in little dashes. There you go. is going to be our vertex. So we've got 1 point right there. Next thing we're going to do is we're going to grab our y-intercept. If we look over here at our little chart, our y-intercept is our c value. So that's this guy up here, this 5. So we just get to straight up go on our axis. 1, 2, 3, 4, 5. Up here at 5. Right there at 5. Axis of symmetry means whatever happens on one side of the line happens on the other side of the line. So we're going to take this and flip it like it was a mirror. So we're going to go, if this is one space to the left of the line, then we're going to go one space to the right of the line. And we're going to go like this. All right. So now we have here, here, and there. We have 3 points. We can make this parabola. Better if we did 5 and plugged in a couple other values. But at this point, all we got is 3, and that's okay right now. So what we're going to do is we're going to just kind of connect them up. And this makes a U shape and not a V shape. This is not an absolute value. Do not use a ruler. No rulers. All right, so this is a U shape. Curve it gently. All right, curve it gently. Oops, my pen's freaking out. There we go. Curve it gently. I mean, that's a pretty sharp U, but it's going to scoop. It is not a V. It is a scoop up and then a scoop up the other way. Like if I hold up a rope and let it just hang between, or if I hold up a cord and let it hang between, and it wasn't a, you know, pre-bent cord. There we go. It makes a U. Let's see if I can get it on my white shirt. There we go. Makes a U. I can't fold this and make a corner without breaking my pen. So it is a U. Do not put a hard angle in there. Okay? That is something I would stress very, very hard in our classroom if we were together. That would be something I would go with you a lot. And you would also be doing 5 points, not 3. But we're going to go with 3 for now because that's what we have. All right. So what we need to do now is we need to describe the domain and range. The domain and range are our vocab terms. That is when we got to describe which X values are true and which Y values are true. So the X values, this does continue up and out in both directions. This is going to keep going. If I could draw up over here, it would continue going way up over there. I don't know if you can even see my pen way up there. It's way up there. It's going to keep going and going and going. And this one's going to keep going and 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 going. It's not really going to flatten out, but my pen's going to keep going and going and going, and it's going to draw a line. Okay, so it keeps going up and up and up and up and up. My pen can only go up so far, so it starts going horizontal. This side keeps going up and up and up and up and up, and then it keeps going horizontal because my pen can only go so far. If you were in my classroom, you would see a couple of dots way high up on the wall and up onto the ceiling, where I've done this a little before and, you know, kind of made dot marks way up on the wall, because they continue on. It's just like those exponential functions. This is an exponential function. It's just going up by an order of 2. So with parabolas, all these, the domain, our X values, is always going to be all real numbers. It's all real numbers. And the range, whoops, we're going to have to put this as an inequality, because our Y values, if we look down here, these ones aren't valid. They're never anywhere on the function. These ones aren't valid. This doesn't start having a value until we get up here to 2. So our Y value, if we think back to those inequalities that we graphed, where we would have, you know, a line and then an arrow like this, and it looked like that, our Y values are starting here, and helps when my pen doesn't freak out. So it's going to start right here, and it's going to include this 2, and it's going to keep going up. So our range is going to be when Y is bigger than or equal to 2. And I will double check on big ideas on how exactly they want you to put in this domain of all real numbers. I think a lot of them are match, and it might be something like all real numbers. It might be something like infinity to infinity, or negative infinity to infinity. I will double check, and I will make sure to put that in the assignments page where I link these videos on how exactly they would like you to word that in big ideas. I just haven't gone and looked at that before I recorded this video, and I don't really want to record the whole thing. Yeah. So I will make that very clear on the assignments page. So if you go back to where you got the link to this video, it should say underneath it in clear words how Big Ideas wants you to, it'll say like Big Ideas wants you to put this like that. All right, so we did graphed it, we described the domain, we described the range. This is our range right here. Okay, so I know it's a lot in these videos. This chapter covers a lot, and it's hard to break this down into smaller chunks. So we're just gonna kind of do one at a time and try and slam our way through it and do what we need to do. All right, and so welcome to the TARDIS. Welcome to the world of Gen Con. This is the kind of stuff that happens at Gen Con. So I think I have 2 more videos for you this section. Okay, one more that's a lesson and one more that's kind of a wrap-up video for us. So I will see you later.